Hello, my name is Mrs Francis and I am the subject leader for science at Hunters Bar Infant School. Our intent in science at Hunters Bar is that all children are taught the essential aspects of knowledge, methods, processes and uses of science, that they have a curiosity and understanding of the world around them, develop a lifelong love of science and are given the opportunity to deepen their scientific knowledge, often referred to as science capital, and learn enquiry skills. What is meant by the term science capital? At Hunters Bar, we recognise that children begin school with different amounts of science capital, and in that we're talking about their science knowledge, their attitudes to science, the skills and their experiences. Additional science capital is gained through not only science lessons but extracurricular activities such as trips and science visitors, as well as community and external links. Below here you'll see that there's some information if you'd like to look at this further that's produced by King's College London. The Department of Education England states that science is a compulsory core subject. So science in Key Stage 1, that's years 1 and 2, builds on the firm foundation of the natural world, which is an early learning goal taught in the reception curriculum. The Science National Curriculum has been designed to ensure that there's a knowledge progression so that all pupils can become competent scientists from reception to year 2. And it's deliberately sequenced so that children get that opportunity to pre-visit and build on knowledge that they already have and revisit concepts across Key Stage 1. Let's focus first on science in reception and the natural world early learning goal. This is split into 3 main areas. The first one is that children explore the natural world around them, observations and drawings, and you can see in these photographs clear evidence that there's plenty of that going on in reception. They also look at similarities and differences between the natural world around them and then contrasting environments. And in this case, they were looking at the Arctic environment and how animals manage to stay warm even though it's incredibly cold. And so they were investigating having blubber in a glove and noticing how their hands stayed warm. The final area is understanding some important processes and changes in the natural world. That might be on a large scale, for example seasons and the change in vegetation and animal life, etc., but also in the changing states of matter, and that might include things actually rotting and breaking down. In this case the pumpkins were actually left to rot and decay, which the children were fascinated by and took great pleasure in telling me how smelly they'd become. Key Stage 1 science then. The principal focus of science teaching in Key Stage 1 is to enable pupils to experience and observe more closely the natural and human world around them. At Hunters Bar, children are very much encouraged to be curious and to ask questions about what they notice. Their understanding of scientific ideas is supported through the use of different types of scientific enquiry so that children can begin to answer their own questions. And they get very much used to that, particularly in Key Stage 1, when they can generate their own ideas of how we're actually going to find something out, what sort of experiment we could do, would it be a fair experiment, how could we make sure that our results were accurate, and they're very much full of ideas. This is how working scientifically tends to look at Key Stage 1. So it might go from asking questions. So you might pose the question, which one of these do you think is the stretchiest if we're looking at materials? Or which one of these do you think weighs the most and have the biggest pull on this piece of material? Just different questions that we'll be asking. Then we do our simple tests, which we've done lots of brainstorming on. Do our test, observe what we record. We might look at books and videos for more information, record what we found out. Is there a pattern? Is there a correlation? Is there a link? Did we find out, did we predict accurately, or the reasons why it didn't work out as well as we expected? And the children get take real ownership of their investigations and their inquiry, which really does help them to focus on the activities. At Key Stage 1 we do follow the national curriculum, and children study similar topics in Year 1 and Year 2, building on that prior learning in reception. So it's progressive, it's sequential learning, which allows children to revisit prior learning, embed it and become confident scientists. I've attempted to demonstrate this on the following slide. So the first area of learning in science would be, we might look at plants. You might find that this is actually split up across the year so that we can take account of those seasonal variations in plants as well. Particularly in Year 1 when we're focused on British trees and we're identifying trees that are deciduous and evergreen. In Year 2 you can see that we start to look at exactly what do plants need, and then we're asking questions like, so does the largest seed grow into the tallest plant? And does it matter which way up I plant my bulb? So you can see already just those inquiry questions coming through. Next area of learning is materials. In Year 1 you'll see that it's very much looking at naming materials, looking at how they feel, how do they feel, are they soft, are they hard, thinking about whether they're cold, their textures, and also are they magnetic. And we're really focusing on the differentiation between the object and the material the object is made of. Building on that, then in Year 2, our investigations, you can see here we've got 3 pairs of tights. Which do you predict will be the stretchiest? And upon investigation you can see it's clearly the navy blue pair, and when we looked at the label inside each of those pairs of tights about what materials are used to make them, we found that that had got the highest percent of lycra, which we know is very stretchy. The pupils here are actually looking at different building materials, that's why they're all looking at the wall there, deciding whether it would absorb moisture or not. And again, just lots of inquiry based learning. I've put these knowledge organisers here just to demonstrate that build up and that progression in their learning, and you can see quite clearly from reception when they're really just focusing on what a material is. So these objects are made of metal, and then it clearly gives you examples of objects not made of metal. And then in Year 1 you can see how we're starting to introduce some key vocab, how we're looking at how we can sort things. And you'll notice, if you can just see it, there's a diagram there of some spoons, and it's the fact that you can have spoons made out of different materials, and actually they love finding out then all the different things that are made out of different materials. So for example, a pencil sharpener might be made out of different materials, a drinking cup might be made out of different materials, and actually it really gets them thinking very much about the different materials that are available. And then in Year 2 we're starting to look at how we can change materials, looking at the forces that we can use, squashing, bending, twisting, stretching, and you can see again how that vocab is then building on the Year 1 vocab, and they're starting to use sort of more scientific terms. Another area of learning in Key Stage 1 is animals, and that does include humans. And you can see here in Year 1 they were looking at sorting different animal groups. So they had birds, and they also had mammals and amphibians, reptiles, etc. And they were cutting out the various animals and sticking them on where they thought, which generated masses of conversation. So it wasn't just a cutting and sticking exercise. It was all about, well, I know that this is a bird, yes, but actually that doesn't fly. So are you sure it's a bird? Well, and so you could hear this conversation that was developing, and really building on their knowledge and their understanding. Also looking at naming parts of the human body, whereas in Year 2 we're then looking at life cycles of different, you can see from insects right the way through to we've got amphibians, etc. And then we're also moving on from in terms of the human, we're not looking at labelling the body, we're actually looking at what we need in a balanced diet. The little slide at the bottom, which is fuel up, these tend to generate huge amounts of discussion, as in which one is the odd one out. And you can imagine there actually isn't an odd one out, but it really starts to engage the children. Well, I think the banana is the odd one out because that's the only one that's a fruit. Well, I think the spaghetti is the odd one out because that's pasta and the others aren't pasta. And they really start to have those raise important observations that other children might not have picked up on, and it gets them all thinking. Seasonal change is focused really on in year 1, and they will identify a tree in the school grounds and maybe sketch it outside, do paintings, etc., as it changes through the seasons. Increasingly, we also do go back to this and revisit this in year 2, measuring the rainfall during the different seasons and looking at the different weather. And then just in year 2, they do living things and their habitats. And in this case, we were looking at a microhabitat, which they found fascinating. Could they find the smallest microhabitat possible, especially for these mini beasts? And you can see that really engaged and tremendous mini beast hunters. So there's 2 forms of science assessment. There's what's referred to as formative assessment, and that's ongoing. That's on a day-to-day basis, where you're observing the children, be it on their carpet and their contribution and the answers that they're giving, through to the work that they're producing, looking at materials that they've completed or investigations that they've done and what level of understanding they've demonstrated when you've asked them questions and had discussions. We're also very keen to ask precise questions, just to really test that conceptual knowledge and the skills, and assess pupils regularly to identify those children who might have got gaps or misunderstandings in their learning. And then we have summative assessment. That is at the end of a unit and might be in the form of a quiz, it might be a short question sheet, both of which though, both forms of assessment we do use in order to monitor the children's progress and to determine whether they will achieve the expected level at the end of year 2. Science enrichment at Hunter Spa is quite extensive. So we have the science club in year 2, which is very popular, and children like to attend that. We do lots of different investigations. Also involved in the Ogden Trust, working in partnership with Sheffield Hallam University and a large group of the local schools in this part of Sheffield, working with their science subject leaders. It's a really great way of enriching our own development, but also bringing new ideas. Moving on with the enrichment, we also visit the park regularly. Parents are invited to come and talk about any of their science in their jobs, and we also have our ducklings that hatch, and our duckling eggs that hatch, and our caterpillars that emerge as butterflies. There's also a large range of different school trips through the year. A STEM activity, so that's science, technology, engineering, maths, that can be a whole school activity. And in this case, last term we actually challenged the children to make a marble run and provided them with a limited amount of equipment really. And once they'd managed to get their marble, it was a lot of trial and error to get their marble to actually go down the full length of their marble run. And once they'd achieved that, then there was challenge. Can you make it go slower? Can you make it go faster? Is there an easier route it could take? Is there a more complicated route? What would happen if we added this piece in? And again, raising all those questions, developing that inquiry, and looking at in particular that sort of resilience and perseverance to investigate. So science isn't always an easy subject for children to access, and it's important that we try and support children who have barriers to their learning. So children are introduced to key vocab before the lesson, so we pre-teach it. And I'm just giving you the example here of the word habitat and what that might mean, and you can see that we use communicating print to try and make that to include a picture, which is quite simple. We also have do know activities. You can see this one here is which sensor you're using, and this will not come up when we're actually teaching sensors. This will be maybe when we're doing materials, when we're doing seasons, and it would just be revisiting some prior learning and looking at recall. Tasks are often broken down into very small steps so that children have got a clear idea of where they're going, and they don't get sort of overwhelmed with a plethora of instructions. Starting point should be a pupil's current understanding, and so take great effort to make sure that we know where those children actually are at that point. We also use concrete resources, make the steps in the process memorable and ensure pupils can recall them. And we refer to the knowledge organisers, the one I demonstrated to you earlier, as well as adult support. So parent involvement and ways to support science at home. I'm sure some of you will have already been involved in some of these activities, but this is just to give you an idea of things that you might not have considered. So there's a huge range of books, planting seeds. You might use something as formal as a science lab kit. There's plenty on the internet of different science experiments that you can do at home. The Western Park Museum, further afield there's Eureka, there's also Magna, all superb days out and really open the children's eyes to science. So here are some websites that you might want to look at in future that will give you plenty of good ideas. So the impact of science curriculum. All teaching staff at Hunters Bar embrace a really positive attitude to science, which ensures good science teaching and learning. So as a result of that, the majority of children achieve the national expectation in science at the end of Key Stage 1 and, importantly, have a greater science capital. I've really enjoyed sharing with you all about science at Hunters Bar, and if you have any questions, then please don't hesitate to get in touch. Thank you.